Good morning children. Last class we have discussed about the wave nature of light and we had seen the various characteristics of electromagnetic waves and characteristics of wave we had discussed. Okay. We had discussed the various characteristics like wavelength of the wave, frequency of the wave, amplitude of the wave and wave number. Okay. So, these were the few characteristics which we had discussed in the previous class. Today we will be solving some numericals based on those characteristics. So, what were they? We had seen that lambda, which is the wavelength of the wave, it is inversely proportional to the frequency of the wave. So, we could have a relation lambda is equals to c by nu or nu is equals to c by lambda, where c is the velocity of light and it had the value 3 into 10 power 8 meter per second. Okay. So, let us take up this question. What is this question saying? Calculate the frequency and wave number of a yellow radiation having wavelength equal to 5800 angstrom. Okay. So, you are asked to calculate frequency. So, frequency of wave. Frequency of the wave will be equal to nu, which is equal to c by lambda. Okay. So, nu is equals to 3 into 10 power 8 meter per second upon lambda क्या हो गया 5800 into 10 power minus 10 मीटर. ये क्यों ऐसा है? क्योंकि जो एंगस्ट्रॉम है 1 एंगस्ट्रॉम इट इज़ इक्वल टू 10 पावर माइनस 10 मीटर. ये वाला रिलेशन यू शुड रिमेंबर. ओके. और हम क्यों कन्वर्ट कर रहे हैं? क्योंकि वेलोसिटी जो है वो मीटर पर सेकेंड में होता है. Okay. So, whatever answer you are getting, that should be the value. So, let me check the value. You also check with your calculation. You get 5.172 into 10 power 14 second inverse. I hope this is the answer you are getting. Okay. 5.172 into 10 power 14 second. दूसरा पूछा है हमें वेव नंबर पूछा है. So, wave number is given by nu bar. That is equal to 1 by lambda. Okay. That is 1 by 5800 into 10 power minus 10 meter. And इसका आंसर तुमको क्या मिलता है? Just calculate and see what answer do you get here. I think you get it as 1.724. You get it as 1.724 into 10 power 6 meter, or if you want to convert it to centimeter, then it would be 1.724 into 10 power 4 centimeter inverse. This is meter inverse because meter is at the denominator. When it goes up, it should be meter inverse. I hope this is clear. Okay. Now come to next question. You can copy down later on. The wavelength range of visible spectrum extends from violet light, which is having a wavelength of 400 nanometer, to red, which is having 750 nanometer. Express these wavelength in frequencies. So, first we will take frequency of violet light. Okay. Frequency of violet light. Again use the same formula. What is it? Nu is equals to c by lambda. C is 3 into 10 power 8 meter per second upon lambda कितना है? 400 nanometer बोला है. So, that is 400 into 10 power minus 9. You know that 1 nanometer it is equal to 10 power minus 9 meter. ये वाला conversion भी तुमको याद रखना है. ये conversion तुम्हें याद रखना है. Every time we are going to use this. So, 1 nanometer is 10 power minus 9 meter. So, answer कितना आता है? That many, this many meters. Okay. So, that many second inverse में आएगा answer. I think your answer should be 7.50 into 10 power 14. ये 3 by 4 हुआ ना, तो 75 ही होगा 3/4. That is 7.50 into 10 power 14 second inverse. Similarly, you calculate frequency for red light. Frequency for red light. That will be again using this formula only, c by lambda. That is 3 into 10 power 8 meter per second upon lambda. How much it is? 750 nanometer. That is 750 into 10 power minus 9 मीटर, और ये तुम्हारा आ जाता है इस आई थिंक 4.00 इंटू 10⁻14 सेकेंड इनवर्स. Okay, so this is how you should be solving this question. Note down so that I can go to the next topic, that is particle nature of light. Okay. Now we will discuss about the particle nature of light. In the previous sections we had seen that light was behaving as a wave because of certain experiments like diffraction, interference. We had studied the characteristics of wave, we had studied the characteristic of an electromagnetic wave, and we had discussed all the points which were showing that light was behaving as a wave. Okay. Now today's topic we will take particle nature of light, that means light behaving as a particle. There were certain experiments which were done, and it was found that light could not be explained in the form of a wave. The best two experiments, or the very famous two experiments which indicated that light does not, or light cannot be expressed as a wave, light cannot be understood as a wave, is the Blackbody radiation and the photoelectric effect. These were the two famous experiments which showed us that light was behaving as a particle, and that is how it led to the conclusion that light has a dual nature, that is, it can behave as a particle, it can behave as a wave. Okay, that is the duality of light. Now we will take the first one, that is Blackbody radiation. Before going into the experiment part, you understand what is a Blackbody. A Blackbody is an ideal body which can absorb radiations of all wavelength, and which can emit also the radiations of all wavelength. Suppose a light is falling on an object. Let me show you a bottle. So this bottle, isn't it? What color does it appear? It appears red in color. Now why does this bottle appear red in color? That is because when white light falls on this bottle or the material with which this bottle is made up of, it absorbs all other radiations except red. The red is the color which is reflected or emitted by that body. Okay, are you understanding? So whenever white light is falling on this bottle, the white light has all the 7 colors, isn't it? Vibgyor, you have learnt about it. So white light, when it falls on this bottle, the material with which this bottle is made up of, it absorbs all other radiations of all the other colors, but it reflects only the red color, and that is why we see the bottle as red color. So any color which we see around us, that is because that color has been reflected by that material on which the light ray is falling. Okay, so that is how you can understand radiation. Followed? Now Blackbody is that body which can absorb all radiations of all wavelength, and it also emits radiations of all wavelength. ठीक है. अब एक और one more thing you should I will tell you that you must have seen when you heat a iron rod. Okay, in the beginning the iron rod, you keep on heating iron rod which is grey in color, okay, or you may say blackish in color, blackish grey in color. So that iron rod, when you start heating in a furnace, initially the rod will appear dull red. Okay, when you heat it, see iron rod, okay, iron rod, when you heat it, what is this triangle showing? It is the symbol for heat. This you are heating in a furnace. Okay, furnace जहाँ पे बहुत हीट प्रोवाइड कर सकते हैं ऐसे, that is the furnace. तो furnace में heat कर रहे हैं iron rod को. So what happens? The iron rod will first appear dull red. Okay, at a particular temperature the iron rod will appear dull red. Then you can say orange red. Okay, और heat करो, ज़्यादा heat करो, more heat, then it will appear orange in color. Then you may find that it appears white in color, white भी दिख जाता है. Or finally you will may observe at very high temperature, you will also find that the iron rod has become blue in color. So when you go on heating the iron rod at very high temperatures, you will find that at different temperatures iron rods show different colors. So what does it indicate? It indicates that at different temperature the light with different colored radiation, different colored wavelength is being emitted. ठीक है, at a temperature T1 when the iron rod appears red in color, उसका मतलब क्या है कि वो जो रेडिएशन है, जो रेड कलर का वेवलेंथ वाला जो रेडिएशन है, that is being reflected. Okay, the radiation with the wavelength of red color is being reflected. That is why that iron rod appears red in color. When you heat more, that is at a temperature T2, the iron rod appears orange in color. That is because the radiation with the wavelength of orange color is being reflected. That is why that orange color appears. In that way, at different temperatures you find that different colored radiations are being emitted out. So that is showing you that with different temperature the color which is reflected is also changing. So they carried out various Blackbody experiments. Various Blackbody experiments were carried out and they tried to plot a graph between the intensity and the wavelength of the radiation, of various radiations. ठीक है, तो intensity means brightness of the color. ठीक है, so intensity and wavelength when they had plotted after carrying out the Blackbody experiments, they got a curve of this sort. ठीक है, this was at temperature T1. Okay. So what do we understand here? That as you increase the wavelength of the light, suppose this is considered to be the origin, you increase the wavelength. So the corresponding intensity of the color was this particular I value. And you keep on increasing the wavelength. At a particular wavelength, you will find that the intensity is maximum. Let me write that wavelength as lambda max. ठीक है, are you understanding? When you are increasing the wavelength of the light, है ना, light is a radiation which has a particular frequency, which has a particular wavelength. So if you increase the wavelength of the light, then you will find that the intensity is also keeping on changing. So you will find at a particular wavelength the intensity of that light is maximum, after which it again comes down. In the beginning it is less, it goes on increasing, that is when you increase the wavelength the intensity is also increasing, and at a particular wavelength the intensity of the light becomes maximum, and after that when you again increase the wavelength the intensity of the light will be going down or it will be reducing. Followed this? So this was at a particular temperature. तो जब हम बोलते हैं कि ये इंटेंसिटी मैक्सिमम है, लैम्डा मैक्स, दैट इज़ द वेवलेंथ ऑफ द लाइट विच इज़ हैविंग हाईएस्ट इंटेंसिटी. ठीक है, तो हम अगर एक आयरन रॉड जब रेड कलर दिखाता है उसका मतलब क्या है कि दिस पर्टिकुलर वेवलेंथ, ये जो वेवलेंथ है वो वेवलेंथ किस लाइट का है? रेड कलर्ड लाइट का है, इसीलिए वो रेड कलर दिखाता है. When the iron rod appears red, what does it mean? That ये जो wavelength है, that wavelength what we call as the lambda max, that wavelength is the wavelength of the red colored light. Okay, suppose this iron rod is showing red color, है ना, तो वो रेड कलर शो कर रहा है, उसका मतलब ये जो वेवलेंथ ऑफ लाइट है दैट इज़ द वेवलेंथ ऑफ द रेड कलर, दैट इज़ वाई इट इज़ बीइंग रिफ्लेक्टेड, इट इज़ द मैक्सिमम, it is having the maximum intensity, that is why it is showing red color. Okay, at this particular temperature red color का intensity highest होता है, इसीलिए वो color reflect होता है. Are you following? The light will show radiations of all color, but maximum intensity कौन सा color का होता है? मैक्सिमम इंटेंसिटी होता है रेड कलर का, दैट इज़ वाई द रेड कलर इज़ बीइंग रिफ्लेक्टेड, ओके। और ये जो लैम्डा मैक्स हम बोलते हैं वो वेवलेंथ किस लाइट का है, रेड कलर्ड लाइट का है। आई होप दिस इज़ क्लियर, ओके। अगेन दूसरे टेम्परेचर पे जब इंटेंसिटी और वेवलेंथ ऑफ अ लाइट वॉज प्लॉटेड, इट गॉट ऐसा दिखा था, इट शोड अ ग्राफ ऑफ दिस सॉर्ट एंड दिस वॉज एट टेम्परेचर T2 और T2 जो है दैट वॉज ग्रेटर दैन T1। आर यू फॉलोइंग? सो T2 ग्रेटर दैन T1 प्लॉटेड बिटवीन द वेवलेंथ एंड इंटेंसिटी ऑफ अ लाइट। तो हमें इस तरह का एक ग्राफ मिला। तो इस तरह का ग्राफ में नाउ व्हाट इज़ द मैक्सिमम इंटेंसिटी एट दिस पर्टिकुलर लैम्डा, ठीक है। अब ये कोई और कलर होगा, ओके, लेट मी टेक इट एज वाइट, ठीक है। ये लाइट क्यों वाइट, द इफ दिस इज द कंडीशन, आयरन रॉड अपीयर्स वाइट इन कलर। वाई वाइट इन कलर? बिकॉज एट दैट टेम्परेचर मैक्सिमम इंटेंसिटी कौन सा कलर्ड लाइट का है, वाइट कलर्ड लाइट का है, दैट इज़ वाई इट अपीयर्स टू बी वाइट इन कलर। ये जो लैम्डा है, ये लैम्डा किसका वेवलेंथ है, वाइट कलर का। फॉलोड एवरीवन? वैसे ही ब्लू कलर। सो दैट वे at different temperatures you get different colors, because at that temperature the maximum intensity will be for that particular light, okay। उसका वेवलेंथ सबसे ज़्यादा इंटेंसिटी प्रोवाइड करता है of that particular color light. That is why we will find that the color of the object appears to be that color, वो color reflect हो जाता है। I hope this is clear, okay। Now when ये तो एक्सपेरिमेंटल ऑब्जर्वेशन था, लेकिन वेव थियोरी से अगर हम थियोरेटिकली कैलकुलेट करें between and find out the relation between intensity and wavelength of a particular light, तो हमें इस तरह का एक ग्राफ मिलता है। मतलब without doing any experiment we are just calculating through by calculations we are trying to get a result. So this ये जो result हमने plot किया, this is the result of theoretical calculation, results of theoretical calculations based on wave theory of light। मतलब wave theory of light के according theoretically when calculations were done we could plot this graph, okay। ये जो dotted lines दिख रहा है वो है result based on wave theory of light। It was the result which was based on wave theory of light, ठीक है। But what did you see here कि at higher wavelengths ये जो curve है that goes in agreement with the experimental results, but at lower wavelength ये जो region है ये सब lower wavelength वाला regions है and higher frequency वाला regions है। You know wavelength and frequency are inversely related, ठीक है। तो at lower wavelength you found that the results of theoretical calculations based on wave theory of light was not coming to be same as the experimental observation results. So that led to the thinking that we cannot only take light as a wave. Light as a wave was not adequate for explaining the nature of light, ठीक है। So that was resolved by Max Planck। तो मैक्स प्लैंक ने कुछ assumptions किए जिस to solve that problem, okay। So what did he say? He said that Max Planck said, or he made some assumptions that molecules absorb or emit radiations as packets of energy. So they absorb or emit radiations as packets of energy, small packets के through light emits radiation, okay। So molecules either they absorb radiations as packets of energy और इट एमिट्स रेडिएशन एज पैकेट्स ऑफ एनर्जी. पैकेट्स ऑफ एनर्जी का कॉन्सेप्ट उन्होंने दिया. एंड दीज एनर्जी पैकेट्स दे आर कॉल्ड एज क्वांटम. मैक्स प्लैंक ने ऐसे छोटे छोटे पैकेट्स ऑफ एनर्जी को क्या कहा? दे कॉल्ड इट एज क्वांटम. सिंगुलर में हम क्वांटम कहते हैं और प्लूरल में हम क्वांटा कहते हैं. ओके, सो दिस वॉज द फर्स्ट ऑब्जर्वेशन या एजम्पशन बोलेंगे इसको. ही अज्यूम्ड दैट मॉलिक्यूल्स absorb or emit radiation. Molecules of the matter, it absorb or emit radiation. Absorb matlab to take in, and emit means to give out radiation as packets of energy and not as wave. ठीक है, so it and these energy packets were called as quantum or quanta. ठीक है. Now the energy of the packet which is represented by E, this energy of the packet was given by a formula E is equal to h nu. E is equal to h nu. ये क्या है? एनर्जी ऑफ द पैकेट. ठीक है, और न्यू क्या है? फ्रीक्वेंसी ऑफ द रेडिएशन विच हैज़ एन एनर्जी E. Okay, so the energy of the packet was given by E is equals to h nu, where nu is the frequency of the radiation. Okay, and every radiation with a particular frequency is associated with some energy, and that is this energy. ठीक है, and what is this h? H is the Planck's constant. It is a constant which was given by Planck's Max Planck only, and its value was 6.626 into 10 power minus 34 joule second. 6.626 into 10 power minus 34 joule second. ठीक है, तो ये assumptions के थ्रू he could solve that argument जो वहाँ पे नहीं हो रहा था. मतलब the experiment result were not coming according to the theoretical result when it was calculated based on the wave theory. To resolve that, Max Planck gave this. What did he say? That light did not travel in form of a wave, but it traveled in form of small energy packets, and it absorbed or radiated energy in the form of small packets of energy called as quantum. Okay, and the energy of this packet was given by E is equals to h nu. What is nu? Nu is the frequency of that radiation. Okay, and E is the energy associated with the radiation of this particular frequency. I hope this is clear. There is one question. Calculate the energy of a radiation with wavelength 5000 angstrom. Calculate the energy of a radiation with wavelength 5000 angstrom. So which formula you can use? This formula only. What is it? E is equal to h nu. अभी nu क्या है? Frequency है. But do we have the frequency here? No. But you know that nu is equal to c by lambda. In the previous sections we have learnt this. So instead of nu, can I write c by lambda here? So how do I get my E? E is equals to h c by lambda. Now lambda is given as 5000 angstrom. ठीक है, अब angstrom का वैल्यू क्या होता है इन टर्म्स ऑफ मीटर? 1 angstrom is equal to 10 power minus 10 मीटर, ये होता है. ठीक है, तो अब इधर 5000 angstrom बोला है, तो लैम्डा क्या हम एक्सप्रेस कर सकते हैं? we can express it as 5000 into 10 power minus 10. That becomes 5 into 10 power minus 7 मीटर, है ना. हमने क्या किया? एंगस्ट्रॉम को मीटर में कन्वर्ट कर दिया. कैसे कन्वर्ट किया? 1 एंगस्ट्रॉम इज 10 पावर माइनस 10 मीटर. सो 10 पावर माइनस 10 मीटर, ये 3 जीरोस इधर हट गया, तो क्या हो जाएगा? 10 पावर माइनस 7 मीटर. ठीक है, और h का वैल्यू हमारे पास है 6.626 इंटू 10 पावर माइनस 34, एंड c का वैल्यू वी नो. व्हाट इज द वैल्यू ऑफ c? You know that h is equal to 6.626 into 10 power minus 34 joule second. ये वैल्यूज़ तुमको याद रखने का. ओके, and the c value, you know, c is the velocity of light, that is 3 into 10 power 8 meter per second. I hope this is clear. तो ये सारी चीज़ है हमारे पास. Then we can calculate E. Okay, you note down this, then I go further. So what did you get there? You got your lambda is 5 into 10 power minus 7 meter. H, you know, it is 6.626 into 10 power minus 34 joule second, and C is 3 into 10 power 8 meter per second. With using that we can calculate E is equal to H. H is 6.626 into 10 power minus 34 joule second. ठीक है. H. C कितना है? C is equal to 3 into 10 power 8 meter per second. ठीक है. Upon what is the value for lambda? 5 into 10 power minus 7 meter. 5 into 10 power minus 7 meter. So here when you calculate, no, you will get some 3.87. I think it is 3.87. I have calculated. It is 3.97. Okay, you get it as 3.97 into 10 power minus 19. 6.626 into 3 divided by 5, you get 3.97. ठीक है. और ये क्या हो जाएगा? माइनस 34 प्लस 8, ये 7 ऊपर चला जाएगा तो प्लस 7 हो जाएगा. दैट इज माइनस 34 प्लस 15. माइनस 34 प्लस 15 इट इज इक्वल टू माइनस 19. अब मीटर और मीटर कैंसिल हो जाएगा, ये मीटर और ये मीटर कैंसिल हो जाएगा. ठीक है. ये पर सेकेंड है, मतलब ये सेकेंड इज इन द यू कैन राइट इट एज मीटर पर सेकेंड को कैसे लिख सकते हैं? सेकेंड इनवर्स लिख सकते हैं. तो ये सेकेंड और ये सेकेंड इनवर्स ये कैंसिल आउट हो जाएगा. बचा क्या? जूल. ठीक है. सो व्हाट डू यू गेट योर एनर्जी इन टर्म्स ऑफ? एनर्जी इज 3.97 इंटू 10 पावर माइनस 19 जूल्स. ठीक है. अब ये जूल्स जो है, इट इज़ नॉट अ कन्वीनियंट यूनिट when you calculate the energy and all. So therefore we will use another unit. और ये जो इस तरह का studies होता है ना, you are using a unit which is 1 electron volt. It is equal to 1.6 into 10 power minus 19 joules. ये वाला formula you have to remember. What is it? 1 electron volt is equal to 1.6 into 10 power minus 19 joules. This is the unit which you will be using frequently. Okay, तो अगर हमें इसको convert करना into electron volt form, see 1 electron volt is equals to 1.6 into 10 power minus 19 joules. Therefore 3.97 into 10 power minus 19 joules will be how many electrons? So if you want to convert this into electrons, you just divide 3.97 into 10 power minus 19 upon 1.6 into 10 power minus 19. That will give you the value in electron volt. I think it will be around 2.48 electron volt. You will get it in terms of 2.48 electron volt. ठीक है. So if you are asked to calculate in electron volt, you should do this calculation. Otherwise you can keep it in the form of joules only. Okay. There is another question. Calculate energy of 1 mole of quanta of radiation whose frequency is 5 into 10 power 14 hertz. तो इधर क्या क्या चीज़ें दी है हमें? इधर भी हमें एनर्जी ही फाइंड करना है, लेकिन नॉट ऑफ 1 फोटोन. ये क्या है? दिस इज एनर्जी ऑफ 1 क्वांटा. Okay, quanta we also call it as photon, that we will come to in the next section. We will come to how it is same only. Okay, so here this is the energy of 1 quanta. Energy of 1 quanta. Here what is asked? 1 mole of quanta. 1 mole मतलब कितना नंबर में हुआ? 6.022 into 10 power 23 होता है numbers में. Okay, so we will find the same formula we will be using. What is it? Energy of 1 quanta E is equals to h nu. ओके, ये फाइंड करेंगे पहले, फिर उसको मोल के साथ 1 मोल के लिए फाइंड कर लेंगे. So you know that your H is 6.626 into 10 power minus 34 जूल सेकेंड. ओके, अब फ्रीक्वेंसी दिया हुआ है 5 इंटू फ्रीक्वेंसी है ना, फ्रीक्वेंसी हम न्यू से एक्सप्रेस करते हैं, दैट इज 5 इंटू 10 पावर 14 हर्ट्ज. सो यू हैव बोथ द क्वांटिटीज, देयरफॉर E is equal to 6.626 into 10 power minus 34 joule second into 5 into 10 power 14 hertz. You can even write it as second inverse. Okay, तो ये दोनों कैंसिल आउट हो जाएगा and you get the value. How much it will be? It will be 5 6 are 30, 5 2s are 10, 13 it will be, 5 6 are 30, 31 3, 6 5 are 30, 33. So 33 and how many? 1 2 3. So it is 33.130 into 10 power minus 34 और plus 14 कितना हो जाता है? minus 20. ठीक है, either this way, this many joules, or how can you write? It is equal to 3.3130 into 10 power minus 19 joules. इस तरह से एक्सप्रेस कर सकते हैं. क्यों? दिस इज द एनर्जी ऑफ वन क्वांटा. ठीक है. नाउ what will be the energy of 1 mole of quanta? Energy of 1 mole of quanta, you have to multiply it with the Avogadro number. Okay. So what will you do? You can write energy of 1 mole of quanta, energy of 1 mole of quanta is equal to 3.313 into 10 power minus 19 into 6.022 into 10 power 23. तो देखो, कैलकुलेट करो, what is the answer you will get here. Just check your answer. Do you get it as 199 So do you get it as these many joules per mole? 199,510 joules per mole. I hope you get this. Okay. So this is how you will be getting your answer. Energy of 1 mole of quanta, you will get it as 199,510 joules per mole. ठीक है. अगर इसको किलो जूल्स में एक्सप्रेस करना है तो जूल्स को किलो जूल्स में, then you should divide it by 1000 or let it be as it is, you keep it. You get your answer as 199,510 joules per mole. Okay. So please note down this. Now we will discuss the next experiment, that is the photoelectric effect. The experimental setup was of this sort. What was it? That there was a discharge tube, a glass tube of this sort. There was the metal plate. Okay. So this is your metal surface or metal plate, any metal we can take. Okay. And this is the metal detector. Okay, it is the electron detector. Okay. Again, this is a metallic plate only. So it is a electron detector, or you can write it as metal detector. Write it as metal detector. So this is a metal detector, ठीक है, which attracted electrons towards it. So when high voltage was applied, when the voltage of a particular value was applied, what could it be found? That this was the positively charged plate and this was the negatively charged plate. Under this condition, what happened? If a light radiation, this is the light radiation of a particular frequency. Okay, it was a light radiation which was made to shine on this metal surface. So when this was done, that is, light was made to shine on this metal surface, it was found that the electrons started coming out instantly and it moved towards the metal detector. It was connected to the positive terminal, so that is why all the electrons, it started moving from the metal plate towards the metal detector. ठीक है, तो that is why this polarity is kept this way. ये metal plate हमने जो metal detector है उसको positively charged रखा और ये जो metal surface है उसको negatively charged रखा. Okay, there was an ammeter. This is an ammeter which was connected here. ये एमीटर क्या बताता है? Since there is a flow of electron, there will be a deflection in the needle of the ammeter, showing that electric current is flowing through it. और वो बताता है कितना electric current वहाँ पे present है. Okay, so what was the setup? There was a setup of this sort. There will be metal plate and the metal detector. Metal plate can be any metal, and when light ray of a particular frequency was allowed to fall on the metal surface, electrons started emitting out from that metal instantly. Please underline this word instantly, means turant electrons got ejected. That is, it came out from the metal plate and started moving towards the metal detector because it is positively charged, and this metal detector is connected to an ammeter. So ammeter showed a deflection and showed the amount of current which was passing through this circuit, through this coil. Followed everyone? This was the setup and this was the observation कि instantly the ejection of electron took place, okay, from the metal plate. Second, what did he do? He started to play with the frequency. That is, what did he do? This experiment was done by Heinrich Hertz. Okay, it was done by Heinrich Hertz. This was the person who had done this experiment. What did he do? The experiment, he started to change the frequency. So the frequency of the radiation was changed. When he took light with very little frequency, he found that there was no electrons being ejected out. Okay. As he increased the frequency, he found that a minimum frequency was required for that light to make the electrons come out from the plate, that is to get the electrons ejected out from the metal surface, and that minimum frequency was called as threshold frequency. Okay? And this threshold frequency was given by the letter nu zero. Okay? And he found that for any light with frequency higher than the threshold frequency, then the electrons got ejected. This was the second observation when he played with frequency, that is, when he changed the frequency of the light, he found that a minimum frequency was required for the ejection of electron from the metal plate, and that minimum frequency is called as threshold frequency. Okay? And any light with frequency higher than the threshold frequency could only eject out the electrons. This was one of the things he observed. Then when the frequency was increased, मतलब थ्रेशोल्ड फ्रीक्वेंसी से हायर फ्रीक्वेंसीज लेने जब लगे तो उन्होंने देखा कि जैसे फ्रीक्वेंसी इंक्रीज करते हैं द काइनेटिक एनर्जी ऑफ द इलेक्ट्रॉन इंक्रीज्ड. काइनेटिक एनर्जी ऑफ द इलेक्ट्रॉन मतलब ये जो इलेक्ट्रॉन जो जिस स्पीड में निकलते हैं बाहर वो स्पीड इंक्रीज हो गया. The kinetic energy of the electrons increased. What did he find? When he increased the frequency of the light, he found that kinetic energy of the frequency was increased, then kinetic energy of the electrons increased. But he did not find any change in the value of current in the ammeter. That indicated what? Ki number of electrons which were being ejected, it was same only. That is why there is no change in current, because current is what? Current is flow of electron only, no? So if he found that there is no change in the value of current which was indicated in the emitter. That means the number of electrons which came out from the metal plate did not change. It remained the same only. जितना इलेक्ट्रॉन्स पहले निकले थे उतने ही इलेक्ट्रॉन्स निकल रहे हैं, लेकिन what is observed कि kinetic energy of the electron is increasing. The electrons which are emitted out, kinetic energy of that electron is increasing. Okay. So, he found when the frequency was increased, kinetic energy of the electron increased, but current does not change. Therefore, number of electrons did not change, number of electrons which came out from the metal plate did not change, but kinetic energy of that electron increased. ठीक है? The third point was intensity. Okay, first you copy down this, then I will talk about intensity. ठीक है? So, when we talked about intensity of radiation, he observed that when intensity of radiation was changed without changing the frequency, he took a light of a particular frequency and he changed the intensities of the light. So, what did he find? That even when he started with very low intensity radiation, the electrons could come out from the metal plate. Even if you took high intensity radiation, then also it could eject electron. So, any intensity of light for a particular frequency ejected out the electron. ठीक है? Number of photoelectrons increased with increase in the intensity of light. यानी electrons का number जो metal plate से निकल रहा है वो increase हो जाता है when you are increasing the intensity of the light. But kinetic energy did not change here. The electrons moved with the same kinetic energy. So, this was the observations which were made when intensity of radiation was played with, that is changed with. You took a radiation of a particular frequency and kept on varying the intensity of that radiation. So, this was the observations made when intensity of radiation was changed for a particular frequency of radiation, then low intensity radiation also ejected out electron and high intensity radiation could also eject electron. But he found that kinetic energy of the electron remained unchanged, but when you increased the intensity of the light, the number of electrons which got ejected from the metal plate increased. Why? How could we come to know? Because the current value in the emitter increased. Okay. So, this is regarding intensity. Okay. So, what were the observations of the photoelectric effect? That there was instant ejection of electrons as soon as the light shined on the metal surface. That was one of the observation. Second observation that was that when frequency was changed, it was found that very low frequency light did not eject out electrons from the metal surface. There was a minimum frequency required for a particular radiation to eject out the electron from the metal surface. So, that minimum frequency was known as the threshold frequency, and any frequencies more than the threshold frequency could bring out the electrons from the metal surface. As frequency increased, frequency of the light was increased, then kinetic energy of the electrons increased, but the number of electrons which were coming out from the metal plates did not increase. It remained the same only. We could find it out from the emitter because it did not show any variation in the current. Okay. Third observation was when the intensity was varied. Frequency of the radiation was fixed, a particular frequency which could emit out the electron from the or which could eject out the electron from the metal plate was taken, and intensity of that of that radiation was carried out. So, intensity was varied. What did they find? That a very low intensity very low intensity wala radiation bhi could eject out electrons, that is number of photoelectrons it increased with increase in intensity of light. Low frequency wala radiation भी electrons को निकालता है from the metal plate, high frequency वाला low intensity wala, not low frequency, low intensity light also could eject out electron, and more intensity light could also eject out electron from the metal plate. What other observation was seen? Ki number of photoelectrons are the electrons only, okay. The photoelectrons increased with increase in intensity of light. अगर तुमने लाइट का इंटेंसिटी इंक्रीज किया तो ज़्यादा नंबर ऑफ इलेक्ट्रॉन्स वर कमिंग आउट, बट काइनेटिक एनर्जी डिड नॉट चेंज, द स्पीड ऑफ द इलेक्ट्रॉन डिड नॉट चेंज. So these were the observations which were made by the photoelectric effect. जो हमने एक्सपेरिमेंट कैरी आउट किया था, तो these were the observations which were made. From these observation we could come to a conclusion that we cannot think light of as a wave, because if it is a wave, then that wave will go and interact with the metal surface and it will take some time to eject out the electron. But in this case, what do you see? We see that there is instant ejection of electron. How do we know that there is an instant ejection of electron? Because as soon as the light falls on the metal surface, there is a deflection seen in the ammeter, and that ammeter shows that a particular amount of current is present in the circuit, in the setup. So that indicated that there was a instant ejection of electron. ठीक है, अगर वेव होगा तो देर विल बी नॉट एन इंस्टेंट इजेक्शन, देर विल बी अ टाइम लैग, क्योंकि वेव पहले मीडियम के साथ इंटरैक्ट करेगा, देन दैट वॉट एवर फिनोमिनन हैज़ टू अकर, इट विल टेक सम टाइम, दैट इज़ द इजेक्शन ऑफ इलेक्ट्रॉन विल टेक सम टाइम. लेकिन इस केस में हमें ऐसा नहीं दिखता, इंस्टेंटली द इलेक्ट्रॉन इज इजेक्टेड. सो वी कुड से दैट light could not be, or wave theory is not adequate to explain the photoelectric effect. Okay. Another thing which was noticed was that intensity of light, which was believed to be as the form of energy, but it was not so. How could we come to know that intensity was not the form of energy? Because when you increased the intensity, डिड यू फाइंड एनी चेंज इन द काइनेटिक एनर्जी? अगर ज़्यादा इंटेंसिटी वाला लाइट है, वो एक फॉर्म ऑफ एनर्जी है, तो मोर एनर्जी इज़ प्रोवाइडेड टू द इलेक्ट्रॉन, टू द मेटल सरफेस, द इलेक्ट्रॉन विल कम आउट विथ मोर काइनेटिक एनर्जी, दैट मीन्स मोर स्पीड. लेकिन यहाँ पे तो तुम देख रहे हो कि काइनेटिक एनर्जी इज़ नॉट चेंजिंग, दैट मीन्स इंटेंसिटी इज़ नॉट द क्वांटिटी विच इज़ considered to be as the form of energy, what it was believed to be. Okay, so experimentally we found out that intensity was not the quantity which was carrying energy of the light, but you could see that when the frequency was increased, kinetic energy of the electron was increased. It showed what? Ki frequency was the quantity which carried the energy of the light. जब तुमने फ्रीक्वेंसी इंक्रीज किया तो काइनेटिक एनर्जी ऑफ दैट इलेक्ट्रॉन इंक्रीज, मतलब मोर एंड मोर एनर्जी वॉज प्रोवाइडेड टू द इलेक्ट्रॉन, दैट इज वाई इट केम आउट विथ हायर काइनेटिक एनर्जी. तो मतलब एनर्जी किसने प्रोवाइड किया वो इलेक्ट्रॉन को? इट वॉज द फ्रीक्वेंसी, द क्वांटिटी वॉज फ्रीक्वेंसी एंड नॉट इंटेंसिटी. इट वॉज बिलीव्ड दैट इंटेंसिटी वॉज द फॉर्म ऑफ एनर्जी एंड विच कुड प्रोवाइड, which was carrying the energy of the light. But it was found experimentally that high intensity light did not increase the kinetic energy of the electron. It was frequency which increased the kinetic energy of the electron. More frequency, more kinetic energy of the electron which came out. So it came to a conclusion that frequency was the quantity which carried out the energy, which carried the energy of the light. Okay. So these was the things which were problems, or which were the observations. Einstein was the person who could solve all the observations, or could explain all the observations which were observed in the photoelectric effect. Okay, so please note this so that I can write the assumptions or the points put forth by Albert Einstein. So what was Albert Einstein's assumptions? Which he explained for the various observations which he had observed in the photoelectric effect. He said that light is a beam of particle and he called them as photons. Okay, Max Planck called it at quantum or quanta. Einstein called that particles as the photons. ठीक है, तो उन्होंने क्या बोला, लाइट इज़ अ बीम ऑफ पार्टिकल। मतलब लाइट बिहेव्ड एज अ पार्टिकल एंड एज सून एज द लाइट फेल ऑन द metal surface, it behaved, you can imagine like a bullet falling on the metal surface and immediately kicking out the electron from the metal surface. So light behaved as a beam of particles. As the beam of particles fell on the metal surface, immediately electrons were emitted out. So he could explain that instant ejection of electron. So he said light is not a wave, but light is behaving as a particle, and that particle, it falls on the metal surface and immediately an electron is kicked out from the metal surface. Okay. Second thing, he said that each photon has an energy associated which is equal to h nu, same as Max Planck. Okay, Max Planck also said that each quantum has an energy of h nu. Same way Einstein also said that each photon has an energy of h nu. ठीक है, तो a minimum energy was required for the ejection of electron, and any radiation with frequency higher than the minimum frequency could remove the electron or eject the electron, and that frequency of light or the light with that frequency has a particular energy which was given by h nu. Okay, it was same as what Max Planck had predicted. Third, he said that intensity of light does not reflect its energy but reflects the number of photons in light. तो intensity of light हमें क्या बताता है? It does not show the energy of the light. It shows the number of photons which can be emitted for a particular intensity of light. वो भी हमने इधर देखा ना, intensity of light. What does it say? That if you are increasing the intensity of light, number of photons also increase. Number of photons mean photoelectrons. Number of photoelectrons are increasing. So what did he say? That energy of light does not reflect it. Intensity of light does not reflect its energy but reflects the number of photons in the light. ठीक है? And that energy of that light is given by this equation. We can find that whatever energy that particular light is having, okay, if I want to show it in form of diagram, this is the metal plate surface. Okay, suppose energy, this light irradiation is having energy E, which is equal to h nu. Then it has to provide some energy to remove an electron, okay, and that energy is called as the binding energy. Binding energy मतलब ये जो इलेक्ट्रॉन है वो प्लेट के साथ बाउंड है और उस इलेक्ट्रॉन को उस प्लेट से निकालने के लिए पर्टिकुलर एनर्जी हैज़ टू बी अप्लाइड, एंड दैट इज कॉल्ड एज द बाइंडिंग एनर्जी ऑफ इलेक्ट्रॉन टू द मेटल सरफेस. ठीक है, तो ये जो रेडिएशन है वो मेटल सरफेस पे गिरता है, ये रेडिएशन का एनर्जी E है विच कैन बी गिवन बाय h nu. अब ये जो एनर्जी है वो एनर्जी, सम पार्ट ऑफ दैट एनर्जी इज यूज्ड टू रिमूव द इलेक्ट्रॉन, और वो एनर्जी है उसको हम कहते हैं बाइंडिंग एनर्जी. ओके, एंड ये बाइंडिंग एनर्जी के अलावा भी उसके पास जो एक्स्ट्रा एनर्जी बचा होगा, दैट एनर्जी इट इज़ गिवन टू द इलेक्ट्रॉन, एंड दैट इज़ द एनर्जी विथ विच द इलेक्ट्रॉन्स कम आउट, एंड दैट विल बी कॉल्ड एज द काइनेटिक एनर्जी ऑफ द इलेक्ट्रॉन. तो ये भी पार्ट क्लियर हो गया कि देयर इज सम मिनिमम एनर्जी विच हैज़ टू बी प्रोवाइडेड to the electron to move out from the metal surface, and that is called as the binding energy denoted by E naught. Okay, और ये जो E naught है उसको हम वर्क फंक्शन भी कहते हैं, which is represented by phi, और ये वर्क फंक्शन इज़ डिफरेंट फॉर डिफरेंट मेटल्स. हर एक मेटल के लिए ये जो वर्क फंक्शन है वो डिफरेंट होता है, मतलब डिफरेंट अमाउंट ऑफ एनर्जी हैज़ टू बी प्रोवाइडेड टू डिफरेंट मेटल्स टू रिमूव एन इलेक्ट्रॉन फ्रॉम द मेटल सरफेस. वो मेटल सरफेस में से अगर एक इलेक्ट्रॉन को निकालना है तो हर एक मेटल के लिए डिफरेंट अमाउंट ऑफ एनर्जी हैज़ टू बी प्रोवाइडेड. ओके, एंड दैट इज़ कॉल्ड एज बाइंडिंग एनर्जी. और जो बचा हुआ एनर्जी है वो एनर्जी इलेक्ट्रॉन्स को प्रोवाइड हो जाता है, इलेक्ट्रॉन्स को दे दिया जाता है, और वो इलेक्ट्रॉन्स कम आउट विथ दैट एनर्जी विच वी कॉल एज द काइनेटिक एनर्जी ऑफ द इलेक्ट्रॉन. ओके, सो फ्रॉम हियर व्हाट डू वी गेट? अनदर इक्वेशन हम कैसे लिख सकते हैं? E इज इक्वल टू E0 प्लस हाफ mv²। ये दूसरा इक्वेशन है, ये भी हम लोग यूज़ करेंगे व्हेन वी सॉल्व द न्यूमेरिकल्स। तो न्यूमेरिकल सॉल्व करने के लिए ये भी यूज़फुल है। E इज़ द एनर्जी ऑफ द रेडिएशन, लाइट रेडिएशन। E0 is the binding energy of the electron to the metal surface. That means the minimum energy which has to be provided to remove an electron from the metal surface. It is also called as work function, ठीक है। और that extra amount of energy which is remaining with the light radiation will be given to the electron, and the electron comes out with that energy which will be called as the kinetic energy of that electron. तो ये सारी चीज़ें उन्होंने एक्सप्लेन कर दिया हमको। ओके, सो दिस इज़ व्हाट वाज एक्सप्लेन्ड बाय अल्बर्ट आइंस्टाइन, एंड ही सेड दैट लाइट इज़ आल्सो हैविंग अ पार्टिकल नेचर। सो these were the assumptions which could explain the observations of the photoelectric effect, and we come to a conclusion that light is having a particle nature. Okay, so we will stop here with this. In the next class we will take up the next topic, that is atomic spectra and topics related to that. Okay, so please note down